Okay, day 2 of series and sequences, looking at recursive sequences. So let me change that color up. So the whole thing about recursive sequences, you can look at the definition here, is you need to know the previous term to find the next term. So explicit yesterday, we're looking at things like, tn is equal to 3n plus 1. So you don't need to know the term before it. There's, if I want the 10th term, I go and I slam in a 10 here. 3 times 10 is 30, plus 1 is 31. Okay, I don't need to know the first term. I don't need to know anything, but recursive formulas, recursive sequences require you to know the term before it. So you get something a little uglier, something like this, for example. So the first term, this says T1, or the first term is 2. If I want to know what the second term is, that's T2. I go 3 times, and this says T and then small n minus 1. So what this is saying is, if I want to know what the first term is, I need to go to the n minus 1 term, which is the term in front of it. So for example, let's look at this right here. If I want to know T7, I'm going to go 3T7 minus 1 plus 5, which is 3T6 plus 5. So I need to know the sixth term and then multiply by 3 and add 5 to it to figure out the seventh term. Okay, so in this case, I need to know the term before it. I take the first term, which is T1. Okay, then I can write T1 in there if I want. So T1 is 2. I said that before, and then plus 5. So here I go 3 times T1, and the value of T1 is 2. So 3 times 2 plus 5, 6 plus 5, 11. Okay, so that's how you do that guy. And if I want to find the third term, T3, I go 3 times the T2. You don't need to write this guy here. You don't really need to write this. I'll write it. But it's 3 times the value of the second term, and the value of the second term we figured out was 11. So 3 times 11 plus 5. So that's 33 plus 5, which is 38. And then you keep going from there. So I need to get the n minus 1 term, okay, the term before it, the value of the term before it, to find the current term. Okay, so we can look at other ones here. This one's even more so recursive, I guess. I don't know if I should say that, but this is saying the first term is minus 1. The second term, so this says T1 is minus 1. T2 is 1. Okay, so the second term is 2. Or sorry, the second term is 1, sorry. So minus 1, and then 1, and then what else do I have here? Well, the third term is going to be generated by saying 2 times the n minus second term. So I'm looking at the third term, so that's 2 terms before the third term, which is the first term. Okay, so this is T3 minus 2, which is T1. So I want the first term. Okay, the value of the first term. The value of the first term was minus 1. Okay, from here. So I want that T1 is equal to minus 1. That goes here. Plus 4 times the n minus 1 term, or the term before the one I'm looking at here. So that is the second term. So it's 2 times 2 terms ago, plus 4 times the last term. So 2 times 2 terms ago is minus 1, and plus 4 times the last term, which was plus 1. Okay, hopefully I didn't confuse you with that. So 2 times 2 values ago, so not 1, but 2 values ago, plus 4 times the previous value, which is there. And then you work that out to be 2, and then that's T2. T3, sorry, T4 is 2 times T2, okay, so T4 minus 2 is T2. T2, the value of T2 is 1, so that goes there. Plus 4 times T3, okay, so here I have 4 minus 1 is T3. We said the value of that is that, and that's that plus that, sorry, which is 6. Now, the whole problem with this is, if at any time you made a mistake, if T3 was wrong, and let's say I made a mistake, who knows, maybe I did. If T3 was wrong, and I put 2 when it should have been 7, or something like that, then T3 is going to be wrong, and T4 is going to be wrong, and T5 is going to be wrong, and everything from there is going to be a mistake. So that's unfortunate. Okay, let's look at this. The first term is 100. Every other term is 1/2 of that. So T1 is 100. T2 is half of that. T3 is half of that. And then if you start doing decimals or fractions, you can keep going from there. T4 and T5. Keep going. The first term is minus 2. The second term is 5. Any other term is the sum of the previous 2 terms. Okay, so T1 is equal to minus 2. T2 is equal to 5. T3 is the 2 previous terms, so it's minus 2 plus 5, which is 3. T4, I'm going to take my previous 2 terms. Okay, so I can come up with a formula here. This says here that that any term value is the value of the two previous terms. So the one before it is n minus 1, and the one before that one is n minus 2. So I go ahead and do that. So T4 is then T3 plus T2, and then I can go here and say T3 is 3, and T4 is 5, and I can add them together to get 8. Okay, and we'll look at more formulas right now. So now we're going to come up with the formulas here. So what's going on here? I start off by saying T1 is 2. So let's do the pattern first, and then we'll figure out how to come up with formulas here. So the pattern here, I have 2, and then I'm going to go 6, then 18. If you look at it, it's times 3, times 3, times 3, times 3. So what I do is I take the previous term, and I multiply it by 3, and I get the next term. So my first term, though, I need to know what the first value is recursive. So T1 is equal to 2. T2 is going to be the term before it. Okay, so T1 times 3. Okay, so in this case, I had 2 times 3, and that's how I got 6. So in general, I take my term, and what I'm going to do is I'm going to take Tn, and I'm going to go with the term in front of it, and I'm going to multiply it by 3. Or you can write it like this, 3 times T n minus 1. Okay, so that's 3. It's the same thing, just written like that. So my formula would be, my recursive formula would be this T1 is equal to 2, and then after that Tn is equal to 3 times Tn minus 1. Let's look at another one. Here, how do I get these numbers here? I'm adding 1, I'm adding 2, I'm adding 3, I'm adding 4. So that gets confusing here. How do I get this? Well, let's see if we can figure this out. Another way to look at it is this. No, is there any way to look at? No, let's go with that. Let's figure this out. T1 is equal to 1, and then I look at this here, and T2 is equal to 1 plus 1. Okay, so I don't know. Let's see what else we got here. T3 is equal to, well, I had my so that's 2. So what I do is I take this 2 and I add to it 2. T4, I have my 4, okay, from the number before, and I add to it 3. T5, let's see how I get this 1, 2, 3, 4, 5. What I'm doing here is I'm taking 7 and I'm adding to it 4. So what I'm doing here is I'm taking the previous value. So for any Tn, I'm taking the value of the term in front of it. So the value of the term in front of it is this. Okay, so we say that the value of the term in front of Tn is the Tn minus 1 term value, and that's how we write that. And what we're adding to it is, look at it here. Here I'm adding 1. For the second term, I'm adding 1. For the third term, I'm adding 2. For the fourth term, I'm adding 3. For the fifth term, I'm adding 4. For the nth term, I'm adding n minus 1. So I'm adding to it this number, subtract 1. Okay, so my recursive formula would be T1 is equal to 1, Tn is equal to Tn minus 1 plus n minus 1. Okay, and you can leave the brackets there or take them off. Okay, what else do we have here? Look at the next series here, or sequence here. I have 4, and then 5, then 20, and 100, and 2,000. I'll give you a second to try to figure out how to get that. Good, you got it? Great. So this is 4 times 5 is 20, 5 times 20 is 100, 20 times 100 is 2,000. Okay, so what I'm working here is that T1 is 4, and T2, I need to know that. Okay, it's 5. I can't just get this one without, I can't get T2 without, out of the blue. So it's a little different than the other one. It's based on the two terms in front of it, so I need the first two terms, 4 and 5. And then if I'm going to get term 3, I'm going, give me term 2 and multiply by term 1. Now, and in general, I'm taking Tn and I'm multiplying by the term in front of it, the value, and the term in front of that one. So this is Tn is equal to Tn minus 1. That's the value of the term in front of this term, and then the 1, 2 in front of it. So here, let's look at this here. 2,000, I want the value of this one, which is Tn minus 1, and this one, which is Tn minus 2. So my whole thing is then, let's get rid of this. My formula is T1 is that, T2 is that, and Tn is that. So that looks hideous, but that's how we do it. Okay, anything else I want to show you here? Now this stuff's straightforward. We'll look at this here. We'll work on this in class here. If you start off, don't forget, if something is decreasing or depreciating, we don't really care about, well, we do care about how much it's depreciating, but when we come up with a formula here, you're going to get your value of your boat, okay, and you're going to multiply by not what's gone, but what remains, if 15% is gone, 85% remains, right? So what you're going to do is you're going to multiply by 0.85 here, not 0.15. Okay, and this is exponential decay. So when we looked at decay, if something disappears, if you lose 15% of your value, that's fine, but we don't. That's not what we're concerned about. We're concerned about what's remaining, and what remains is 100 subtract 15%, which is 85%. Okay, I hope that made sense. This stuff could be tricky. Practice it and work on the formatting and that sort of thing. Take care.